This is the third tutorial on the chapter mole concept stoichiometry, and in this we're going to finish it up by just doing a few questions here. This one here I've picked out is from the ICSE 2010 paper, and it's a straight 5-mark question. You can see there are 5 parts here. Now these are the questions that you can expect at least one of these to come, either in section A, it's usually in section B, but you need to know how to do these for sure. Now the first part requires you to just write down the equation for the reaction. Now you should know this reaction. Under HCl also you will do this reaction. So this is not really a mole concept question, the first part, but I'll tell you what this has to do with mole concept. So it's CaCO3 plus HCl gives you CaCl2, and it gives you H2O, and the last thing it'll give you is CO2. Okay, so what we first have to do to solve any stoichiometry questions is balance the equation. Now I've balanced it from before, but it comes out to be just 2HCl, the rest is all balanced. So our first part is done. Now what you need to know is that first part is that what you need to know now is that for now the ratio here is 1:2. Basically now if you put in 1 mole of CaCO3 and you put in 2 moles of HCl, it will form 1 mole over here of CaCl2, 1 mole of H2O, 1 mole of CO2. That's what will happen. Now if say you change these to you double all of these, so say you provide 2 moles of CaCO3 and you provide 4 moles of HCl, then these will all be 2 2 2. It's basically that this ratio of 1:2 over here, 1 1 1, this will remain the same. Also there's a concept of limiting reagent, which is in the reactants, that is these two, the one that is in lesser quantity with respect to their mole ratio will decide how much of the product is formed. It sounds complicated right now, but you'll understand in a second. Um, Now you know that the ratio has to be 1:2. So if you provide 1 mole of CaCO3 and you provide 3 moles of HCl, what do you think will happen? Now the ratio has to be 1:2. So we have to try and maximize the output. So we'll definitely be using this whole 1 mole over here. But since the ratio is 1:2, we can only use 2 over here. So what will happen is that 1 mole of HCl will be unused. It will be unused. It won't take part in the reaction. And that means that HCl is in excess. The same thing we could do, say we had 1 mole, sorry, no, say we had 2 moles of CaCO3 and we had 2 moles of HCl. Now the ratio that we need is 1:2, but this is 1:1. If you want to use up all the CaCO3, you're going to need 4 moles of HCl, which you clearly don't have here. So instead, you make this the limiting reagent. HCl here will be the limiting reagent, and CaCO3 will be in excess. So the ratio will then be 1:2, and there'll be 2 moles of HCl. So in this case, there will be just 1 mole of CaCO3 used, so 1 mole will go unused. So you just need to compare that if the ratio is 1:2 or it's 1:3, whatever it is, just which one can be used the maximum. And the other one will be in excess, so some of it will be left over, but whatever happens, you have to stick by that ratio. I'm just gonna erase all this, need more space. So the second part of the question tells you that what is the mass of 4.5 moles of calcium carbonate. Straightforward question. You know that by now you know that 1 mole of CaCO3 is 100 grams. So simple unitary method, you can do this mentally. So 4.5 moles will give you 4.5 into 100 and upon 1. So 4.5 upon 100, which is 450 grams. So this is your second part done. Now third one asks you what is the volume of carbon dioxide liberated at STP. Now I'm gonna remove this again because to explain this I'm gonna need a bit of space under the reaction. Just take this here. Okay, so we've been given that the 4.5 moles of calcium carbonate, and we've been given that we haven't been told how much HCl there is, so it's just assumed that it is in excess. So over here we can write 4.5 moles. So this HCl, actually if you have 4.5 of CaCO3, that means that 9 moles of HCl will be needed. So let's assume we have all 9 moles. So 9 comes here. Now all of these are 1 as well, right, just like CaCO3. So for these also there'll be 4.5, 4.5, 4.5. So we need to concentrate in this question on just the last part, which is how much carbon dioxide is liberated at STP. So we already know that 22.4 liters of any gas is equal to 1 mole. So now we have 4.5 moles. So we're just going to write this down here. 1 mole gives you 22.4 liters. And so what you need to find is how much does 4.5 moles give. Now to save time, I'm going to get out the calculator. So we do 4.5 into 22.4, so we get 100.8. So here we get 100.8 liters, and that's our answer. So that is the third part done as well. Now what mass of calcium chloride is formed? Now you know from here that there are 4.5 moles formed. Again, same methodology. Find the mass of 1 mole. Now you know that Ca. Actually, in the question, they've given you the mass, relative molecular mass of both calcium carbonate and calcium chloride, but I haven't done that just so you get familiar with how to find it. Now, in the CaCl2, what will be given to you is the mass of Ca, which is 40, and the mass of Cl, which is 35.5. So you're going to take 140, just one of them, and you have two Cl's. So 35.5 into 2, you get 71. So the mass of CaCl2, the molar mass, is 111 grams. So you know that 1 mole gives this much. So how much will 4.5 give? So again, it's just cross multiplying unitary method. So 4.5 into 111, and we get 499.5. So 499.5. Of course you won't have calculators in your exam, but I mean it takes a minute to solve these, just multiplying. I'm not doing it here just to save time on the video. The last part here says how many moles of HCl are used in this reaction. So we've calculated that right in the beginning. Write the answer directly, 9 moles. And the reason, I hope you're clear, you've been given 4.5 moles of CaCO3, and if you've been given say 1 mole, then you must use 2 moles of HCl. So here, since you have 4.5 moles, you just double it and you need to use 9 moles of HCl. So this is how you go about these questions. That's about it really. Then there are other types of questions. Like one simple one is how many moles of CO2 are there in 44.8 liters? So you know that 22.4 liters is 1 mole, and let this be x. So when you cross multiply, you get x is equal to 44.8 upon 22.4. So cut, and you get 2 moles. Also, you should remember these numbers which are completely divisible or completely divide 22.4. There's 44.8, which is double, of course. We just solved it. There is 11.2, which is half. There is 5.6, which is 1/4, and that's about as far as they go. And I'm just telling you this so that it stays in your mind, and immediately when you look at the sum, you can figure out how many moles it is. Of course, you can multiply on the spot as well, but it's just to save time since chem is a short paper. So just familiarize yourself. If you do a few questions, it'll automatically become familiar. So I guess that's the best way. Also, there are questions which are based on empirical formula. Um, this is one of them. Now, this sum is from a paper in, I think this is 2001, yeah, so long ago. But these are the type of questions that you can expect. I'm just gonna read it out. I'm just gonna erase this before we move on. Okay. So the question says, I'm just gonna read it out, not gonna write it. A metal M forms a volatile chloride containing 65.5% chlorine. If the density of the chlorine relative to hydrogen is 162.5, find the molecular formula of chloride. Now, all we need to do in these questions, where we've been given the relative, sorry, not the relative, but the percentage composition is, and the empirical formula as well. All we have to do in these questions is make a few columns here and make one row each for each element. So in this case, we have just two elements. We have M and we have Cl here. Now the first column will be percentage, the percentage that you've been given. So in this question, it's been given that 65.5% chlorine, and so obviously you just to get the percentage composition of M, just minus this number from 100, so you will get 34.5. Now the second column will be atomic weight. So Cl we know is 35.5, and molecular weight of M is given in the question as 56. Now the third column, sorry, not the last. All you have to do is divide the first column by the second column. So it's basically percent divided by weight. So in this case, it will be 34.5 upon 56. Let's just use the calculator for this. 34.5 divided by 56. So nearly, it's around 0.6. Remember, you can round off in chem because the math is really not important. Now we do the same for chlorine, 65.5 upon 35.5. Again, calculator. 65.5 divided by 35.5. So we get 1.8 something, so let's write it as 1.8. Now in the last column, it's called the simplest ratio column. Just write ratio here. So you can see that this is 0.6 over here and this is 1.8 here. Basically you need to try and find a factor between these two. In this question it's clear that the factor will be 0.6, so you can write 0.6 upon and you can write 1.8 here. Now if you divide both these by 0.6, you'll get 1 over here and you'll get 3 over here. So you're basically looking for the simplest whole number ratio. Just find a common divisor such that you get two whole numbers over here. And in the other some of the other sums, it'll be much simpler to spot. They'll be in whole numbers anyway. You'll see when you do the questions yourself. So here we got the simplest whole number ratio as 1:3, and this is actually your empirical formula. So you'll have MCl3. This is empirical formula, and the question asks us to find the molecular formula of the chloride. Now the first step here is to find the weight of the empirical formula. So you actually find the weight of this compound. So M is 56 and Cl is 3, so 106.5, so it comes out to be 162.5. That is the empirical formula weight. You shouldn't write grams over here, no units right now. It could either be AMU or that, whether you're taking a molecule or a mole. Anyway, that's not important. Then the next step is to find the molecular weight. Now the molecular weight, either you are given this or you are given vapor density. This is where vapor density comes in use. We did the formula before. MW is equal to 2VD. So in cases where you've been given the VD, like this one where you've been given that chlorine is 162.5, all you have to do is multiply 2 into the VD and get the molecular weight. What you do with the molecular weight, I'll come to that right now. But in most of the questions, they give you molecular weight directly. But since here in this question they've given chlorine's VD as what is it, 162.5. You can see that it's going to cut already. So we write this as, this will become 325. Now when you have an empirical formula, let's take CH for example, and you have C6H6. CH is the empirical formula of C6H6. Now the molecular weight, which is the weight of benzene C6H6 upon the empirical formula weight, which over here is the weight of CH, is a variable called N. It's always molecular weight upon empirical formula weight, and when you get this value, in this case it will be 6. Now if you know that N is 6 and you know the empirical formula and you want to know what is the molecular formula, suppose you don't know this over here, all you need to do is multiply CH by 6. Make this a 6 over here, so you get C6H6. Same thing we're going to apply over here. MW upon the empirical formula weight, which is it will cut here, so 325 by 162.5, so this will cut by 2, so this is N is equal to 2. So as you said before, to get the molecular formula, all you need to do is multiply the empirical formula by 2, so it'll become M2Cl6, and that's your final answer. I suggest you, there are loads of questions in many of the books. In Anita Prasad, there are loads. In the Together With book, there are many useful ones. So I suggest that the best way to do this chapter is to actually practice the numericals. I think the minimum weightage that you get is around 10 marks. So it's like 1/8 of the paper, and I think you need to do this chapter really, really well. It's also used in most of the other chapters, and it's very important after class 10 as well. So if you don't get it right, I suggest you ask someone, ask one of your teachers, or you could ask us as well. But that's it for now, and we'll be back with the next chapter.